Hello and welcome to Mr. Wiley Teaches Math. Today we're going to be discussing composite and prime numbers. First thing you need to know is that a prime number has exactly two factors. You remember from the other day, a factor is a number that divides evenly without leaving a remainder. So a prime number has only two factors, one in itself. Seven would be a good example of this because the numbers that divide evenly into 7 without leaving a remainder are 1 and 7. A composite number has more than two factors. An example of this could be 6, because 6 divides evenly by 1, 2, 3, and 6. So it's a composite number. It has more than two factors, more than just one in itself. Prime factorization is a process where we can take any composite number and break it down to its prime factors. This works for any number, and for us, let's start with 40, which is a composite number, and let's think of any two numbers that divide evenly into 40. So in this case, let's do 4 multiplied by 10. Then we can check that out. 4 times 10 is 40. Okay, we're all right there. I look at each of these numbers. 4, is this prime or is this composite? Well, I know that 4 has more factors because 1, 2, and 4. So it's not a prime number. If this isn't a prime number, just like I did with the 40, I'm going to break it down a little bit more and think of two numbers that multiply together to give me 4. In this case, I think I have to go with 2 times 2 because 1 doesn't help me out anyway. Then I can look at 10. I think pretty sure 10 is composite as well. So I can break 10 down into two numbers. And I think in this case it would be 2 times 5. I look at these numbers. 2 is a prime number because it only divides by 1 in itself. 5 is a prime number because it only divides by 1 in itself. So if we go across the bottom, these should be our prime factors. 2 times 2 is 4, times 2 is 8, 8 times 5 is 40. It still equals the top number. So the prime factors of 40 are 2, 2, 2, and 5. The neat thing about this is we could have done any number. We could have chosen any sequence there. We didn't have to start with 4 and 10. So let's do another one. Let's choose some different numbers. And let's start with 5 times 8, which is 40. 5 multiplied by 8. In this case, I get a prime number right away. I want to keep it. So I'm just going to bring it down, but I'm not going to break it down anymore because I can't. 8 is composite, so I am going to break it down. In this case, I'm going to do 4 times 2. So 5 times 4 is 20. 20 times 2 is 40. Okay, I'm still all right. Bring down my 5 again. 4 is composite. I have to continue to break it down. 2 times 2. And I was finished with this because it was prime. I end up with the same numbers as I did before, the same prime factors. These two are equal to each other. The order is different, but it doesn't matter what I start with, 4 times 10 or 5 times 8. I'm always going to end up with the same prime factors. Maybe the order is going to be a little bit different. Let's try a different number because some of these work out very quickly. 25, well, if there's only two numbers that divide evenly into 25 other than 1 in itself, and that was 5 times 5. 5 times 5 is 25, and I look at 5, it is prime. 5 is also prime, so my prime factors of 25 are 5 and 5. Some numbers take a little bit more work, like 36. A strategy to use are try to think of two larger composite numbers that divide into 36. And in this case, we could do 6 times 6. 6 times 6 is 36. 6 is composite, so I'm going to continue to break it down. 3 times 2, and 6 again. 3 times 2. 3 times 2 is 6. 6 times 3 is 18. Times 2 is 36. It still works out. So the prime factors of 36 are 3, 2, 3, and 2. Again, we could have done that in different orders. We could have done 36. We could have started with 12 times 3. By starting with a large with a prime number and a large composite number, we're going to end up with a larger tree, but we're going to end up with the same prime factors at the end. In this case, I'm going to go 4 times 3 times 3. 4 is composite. I have to keep going. 2 times 2 times 3 times 3. So it took me more steps, more branches I went down, but I end up with the same again. 2 2s, 1 2, 1 2, and 2 3s. So the same prime factors. Okay, so that's composite and prime factors. Now we know how to find prime factorization. We're going to use that in future lessons. Thanks for watching, and be sure to find the assignment pages and additional examples in the class websites.